Okay, C+ guy here is back, and I have another video for you. So today we're going to talk about passing by reference. If you're coming from C, this is going to be new to you, and this is a very powerful feature that C++ provides. Let's get started. And we're back. Let's do a quick review of how we would modify an object outside of a C function. You would use a pointer. We would use the dereference operator right here. And then we would pass the pointer in, and then we would act upon the object by using indirect access in memory, and we would modify it. And this works very well if you've done C coding for any amount of time. You're using pointers all over the place, but it can get quite messy. The other way you can pass a value in a function is simply by copying it in. With no dereference operator, you're acting on it inside the function, but once you leave the function, that's it. It's gone. Also with C, you can return values by either copying them, passing back a pointer. So in this first example, we do an operation on two integers, and we copy it back as an integer where the type is specified in the function signature. Also, you can pass back a pointer. Now this example is a little bit crude, but you get the point. You allocate some memory, you do the addition, you store the result. You have to initialize the pointer first, and then when we're done, we pass back the address of result out to the parent of this function that is calling this function. Once again, I want to point out, you end up with all this kind of sloppy pointer notation all over the place. And in a simple example like this, it's easy to see what's going on, but as things get more and more complicated, your eyes end up seeing a sea of dereference operators, and it can get quite messy. C++ addresses this. So in C++, we would use the reference operator, or the ampersand symbol. And now when we act upon a variable outside of our function call, we act on it directly. The key takeaway here is when you pass by a reference, and what a reference is an initialized pointer. So when you pass a value by reference, you don't have to have a pointer. You don't have to create a pointer. You don't have to get the address of the variable and pass it in. This is the kind of crazy stuff you had to do in C. You'd have to initialize the pointer by getting the address of what you want to modify. Then you have to take this pointer, then pass it in. Or you do some crazy notation like this, where you would grab the address of number, cast it to a different type, things like this. When you pass by reference in C++, a lot of this type of notation gets eliminated. So here's the bottom line up front. Use pass by reference in almost every case, because when you do pass by reference, you're not going to copy in the object. You're not going to copy in large amounts of data. The only time you want to pass by value is if it's a simple native type and you don't intend on modifying it externally. If you follow that simple rule of passing by reference in most cases, it's easy to remember. And you will see certain cases where, hey, I'm only passing an integer value. Why do I gotta pass by reference? And just copying doesn't make any sense. And those are the cases where you would do a pass by value. Okay, so let's move on to some code examples. Okay, and we're back. So in this example, what I did is I put together some code that modifies the time structure that we would use to set the time on a Linux system. Although this is Windows, but I worked around it. So starting with a global instantiation of TM called device time, we're going to call this function, but we're going to pass in by pointer to set system date time. And we have to get the address of that by using the, what I call like the reverse reference operator, or referencing. Some people call it referencing. Anyway, the pointer is passed into here, and then we have to act upon this external object inside this function by using pointers all the way through. And I will quickly run this, and it does work. It did change my system time. So give me a second, and I will change this to the C++ compiler. Okay, and we're back. So the first thing I want to do is, since it's now a C++ program, we don't need this anymore. We are going to pass by reference. Sometimes you'll see it like this, sometimes you'll see it like this. And get rid of the P underscore because it's no longer a pointer. Okay, I've refactored that, and we will get rid of the arrow notation. Now we just use simple dot notation. All right, I went ahead and refactored that, and we'll see if it builds. I think there's one other error, and yes. We no longer have to pass in the address of device time. We just pass it in by a reference. We just use the same name. All right, it does build. Unfortunately, the Windows API, system time and set system time does work by pointer, so I can't change that. If you look at this signature, you'll see it's a pointer. But that's okay. A lot of times your operating system calls stick to the C standard. And if I run this, and it works. As a quick recap, we have a function, we want to modify an external object or variable. We do it by passing by reference. We don't want to copy this in each time. If I were to do this, it would copy this every single time it's called. Now, this isn't a big structure, but there are times where you're going to have big ones, but with a lot of data in it. Or maybe you're on a restrained system, such as embedded. We can't have that. So always the go-to, like I said earlier, is to pass by reference pretty much every single time. Now, if we had a external variable up here, like, and let's say we wanted to act upon that, we could do this. All right, and then we could act on this externally. Let's say we don't need to modify this. Let's say this is a constant parameter that we're passing into the function. Let's say it's something like bool, use UTC, and we want to make it true. Just an example. There's no need to pass by reference. It's gonna be copied in, and we're gonna use it right away. It's gonna go to the register. So it doesn't make sense to pass by reference here. Now, that's a judgment call you have to make as a developer, but it's gonna be pretty obvious. So all your native types like int, or uint32, or long, float, all of those are all gonna fit inside of a register. So it doesn't make sense to do a pass by reference. The only time you would want to do that is when you want to modify the variable outside. So you can have function arguments, some will be in and some will be out. The input ones would only be passed by value. Outputs would be passed by reference. All right, give me a second. I am going to put this back the way it was. One final thing I wanted to show you is you can also return by reference. So let's say I created a static variable or object inside of this function right here of the type system time. So I want to return this when I exit the function. And because it's static, it's persistent in memory. But rather than return a pointer to it, I can return a reference to it. And you simply just use the reference operator just like this, just like you would with a pointer. And the way you would implement it is, I used auto, but it's the same thing. And now reference is automatically, now my variable ref is now the same thing as if I was calling this directly right here. So this video, just like my other ones, are designed for developers that are very fluent in C, but maybe don't have quite the grasp of C++ yet, or they want to learn C++ better and take steps. So I am picking topics that give the C developer the most bang for the buck when they use the C++ compiler, and pass by reference is definitely at one of the top ones on my list. Just like in my other previous videos where I covered the auto keyword or struct versus class, all the benefits you get from using C++. Even if you want to just code C style, you can use things like pass by reference and the STL library to improve your time to market, improve the quality of your code and improve safety. One of the things C++ does is, and you can see by pass by reference, is you get rid of a lot of the pointer notation. Pointers are infamous in C for causing so many issues, for either not being initialized properly, initialized when you allocated some memory, you forgot to deallocate it. In C++, they kind of prevent you from making those mistakes and also make the code more readable. Under the hood, it's still running fast as hell, C or C++ compiled, and that's the benefit you have, and that's the whole reason I am doing this. So any questions or comments, please leave them below. Please like and subscribe. Apologize, my throat is a little, I think I'm coming down with a cold or something. If that, have a happy new year, and I will see you on the next one.